Hello friends, we are discussing alcohol, phenols and ethers. In this lecture, we have planned to study phenols, preparation of phenols from various compounds, reactions of phenols, ethers, etc. So friends, let us consider what is meant by phenols. Phenols are the compounds in which one or more hydroxyl groups OH is directly attached to an aromatic ring is called phenols. Thus, phenols have general formula AROH. For example, so this is a aromatic ring having a hydroxyl group that is known as a phenol. Phenol is also known as a carbolic acid. So this is also another example of phenols. It is known as orthocresol. Then next one is beta-naphthol. So in beta-naphthol there are two aromatic rings having a hydroxyl group at beta carbon. So this is a resorcinol. Benzene having a two hydroxyl group at meta position with respect to each other. Then next compound is pyrogalol. Pyrogalol having a 3-hydroxyl group attached vicinally to each other. So these are more phenols. So this is again phenol having a ortho meta para positions. So this is a orthochlorophenol. This is next one is metabromophenol, and one more compound that is a parachlorophenol. So this is again parachlorophenol, then 2,4,6-tribromophenol. Next one is 2,4-dimethylphenol, and next one is 2,4,6-trinitrophenol. This compound is also known as a picric acid. So we have seen several examples of phenols, substituted phenols and simple phenol. Now we are going to discuss how phenols can be prepared. So preparation of phenols. So first reaction for preparation of phenol is cumene hydroperoxide. In this method, cumene can be obtained from benzene and propene by Friedel-Crafts alkylation reaction. It is represented as below. So this is a benzene. Benzene reacted with propene in presence of phosphoric acid H3PO4 at elevated temperature 250 degrees Celsius. In first reaction, we get isopropyl benzene, that means cumene, and this cumene can be used for preparation of phenol in next reaction. Cumene is treated with at elevated temperature getting cumene hydroperoxide, then it is treated with 10% sulfuric acid, undergoes hydrolytic rearrangement to give the desired product, phenol and side product acetone. So this is the reaction for obtaining phenol from cumene. So this is a cumene isopropyl benzene. It is reacted with oxygen at elevated temperature in the range 95 to 125 degrees Celsius in presence of air. In this reaction, air oxidation occur, and thus there is a formation of cumene hydroperoxide. So this is a cumene hydroperoxide. This cumene hydroperoxide in presence of sulfuric acid and water at certain temperature, it gives phenol and acetone. Phenols can be obtained by another method from diazonium salts. When aniline reacted with sodium nitrite in presence of HCl, there is a diazotization reaction, formation of benzene diazonium chloride, and this diazonium salt, when reacted with water and hydrochloric acid at certain temperature, gives phenol. So these are the two methods for preparation of phenols. Friends, now we are going to discuss reactions of phenols. First type of reaction shown by phenol is an electrophilic substitution reaction. Mostly, phenol shows electrophilic substitution reaction. Other reactions such as nucleophilic substitution reactions are very little. Mostly, it is favored electrophilic substitution reaction. First reaction of this type is nitration. So what happens in nitration? Phenol, when reacted with dilute HNO3, it gives orthonitrophenol and paranitrophenol. In this reaction, one of the hydrogen atom of aromatic ring from ortho and para position are substituted by an electrophile nitro group. Thus, we get orthonitrophenol and paranitrophenol. Second reaction is halogenation reaction. In halogenation reaction, phenol, when reacted with bromine in water, one of the hydrogen or sometimes many hydrogens, hydrogens from second carbon, fourth carbon and sixth carbon are get replaced by a bromine atom. Thus, there is a formation of yellowish colored product that is a 2,4,6-tribromophene. So, this is a phenol. When phenol reacted with twice Br2 in carbon tetrachloride, it gives orthobromophenol and parabromophenol. Next reaction is sulfonation reaction. In sulfonation reaction, when phenol reacted with concentrated sulfuric acid, it gives orthophenol sulfonic acid, or we can also say orthohydroxybenzene sulfonic acid. This reaction occurs at 25 degrees Celsius. There is elimination of water. So this is also an electrophilic substitution reaction of phenol. So this is again phenol. Phenol when reacted with concentrated sulfuric acid at high temperature, elevated temperature, 100 degrees centigrade, we get paraphenol sulfonic acid or parahydroxybenzene sulfonic acid. Friends, in these two reactions, reagents and reactants are same, only change in temperature. At high temperature, phenol gives para-substituted benzene sulfonic acid, while at room temperature, phenol gives orthohydroxybenzene sulfonic acid. So this is the very typical reaction. Next reaction is Riemann-Tiemann reaction. So in Riemann-Tiemann reaction, when salicylaldehyde, when phenol is reacted with chloroform in presence of sodium hydroxide, it gives salicylaldehyde. While phenol when reacted with carbon tetrachloride and sodium hydroxide, it gives salicylic acid. So formation of salicylaldehyde from phenol, that is when phenol reacted with chloroform CHCl3 in presence of sodium hydroxide, formation of salicylaldehyde occur, one formyl group is get introduced to the ortho position. This reaction is known as a Riemann-Tiemann reaction. So next reaction of phenol is Gattermann-Koch reaction. In this reaction, what happens when benzene is reacted with carbon monoxide in acidic medium in presence of anhydrous aluminum chloride or cuprous chloride gives benzaldehyde. Reaction is known as Gattermann-Koch reaction. So this is the benzene reacted with carbon monoxide in presence of hydrochloric acid, and catalyst is used anhydrous AlCl3 or cuprous chloride. We get a formation of there is an insertion of formyl group in the aromatic ring, that is a formation of benzaldehyde. So reaction is designated as Gatterman-Koch reaction. Our next reaction is Hoben-Hoek condensation. So, in this reaction, when substituted phenol reacted with alkyl nitrile in presence of hydrogen chloride and zinc chloride, yields para-substituted hydroxy ketone. If para position is blocked, then we get orthohydroxy ketone. The reaction is known as Hoben-Hoek synthesis. So this is a phenol, substituted phenol. We have a substituents R1, R2, R3, R4, means all four positions are blocked by various types of substituents, and when there is only one position is open or having a proton and reacted with methyl nitrile in presence of zinc chloride or HCl, we get a insertion of this CH3CO, that is a acetyl group. We get a formation of substituted orthohydroxy acetophenone. So friends, this is known as a Hoben-Hoek condensation reaction. Next reaction is Schouten-Baumann reaction. So what is meant by Schouten-Baumann reaction? The acylation of phenols and amines from acyl halides, acyl chlorides or anhydride in aqueous alkaline solution of NaOH is known as Schouten-Baumann reaction. So in this reaction, see here, this is a phenol. It is reacted with benzoyl chloride in presence of aqueous NaOH. There is formation of phenyl benzoate. We get an ester and NaCl and H2 as a byproduct. So this is known as Schouten-Baumann reaction. That means there is a acylation of phenol. Our next point from this chapter is ethers. In ethers, we might know different kinds of ethers. We have a ether means this is an organic compound having a COC linkage, ROR linkage. So such a type of linkage is known as an ether linkage. Ethers are of different types. There are two types of ether basically, symmetrical ethers and unsymmetrical ethers. These ethers can be cleaved by using different kinds of reagent. Especially ethers are cleaved by using hydroiodic acid. Thus, ethers are readily cleaved by cold hydroiodic acid. When we use cold hydroiodic acid, diethyl ether can be cleaved. Diethyl ether reacts with cold concentrated HI, cleaved the ether linkage into alcohol and halide. So this is a diethyl ether. When reacted with hydroiodic acid at cold condition at 0 degrees Celsius, we get ethanol and ethyl iodide. So this is a unsymmetrical ether. The first ether, this is a diethyl ether, was a symmetrical ether because both sides having a symmetrical group. But this reaction this compound having a ethyl group from left hand side and right hand side having a methyl group. Therefore, it is a unsymmetrical ether. This unsymmetrical ether, when reacted with hydroiodic acid at 0 degrees Celsius, we get a ethanol and methyl iodide. So this is the reaction at cold condition. But when we use hot hydroiodic acid, what happens? See here. So diethyl ether reacts with concentrated hydroiodic acid in hot condition, forms ethyl iodide. So this is the reaction. So this is a diethyl ether reacted with hydroiodic acid at cold at high temperature. At cold condition at 0 degrees Celsius, it gives ethyl alcohol and ethyl iodide. But when once this product are formed, when it is heated, it gives, we get a ethyl iodide, and this ethyl iodide is the final product in this reaction. So this is the one more reaction. This is the anisole. When anisole reacted with hydroiodic acid, it gives phenol and methyl iodide. So this is also ether. This is a phenyl group and this is a methyl group. This is the type of unsymmetrical ether. So friends, in this way, we have finished the third chapter, that is alcohols, phenols and ethers. Totally, there was three chapters. There were three chapters. We have finished this chapter. You prepare this chapter very well. Thank you very much. Thank you.